Hello, and welcome to a quick review of 4.4 that we covered a little bit with limits in chapter 2, and these are going to help us with section 4.4 in this chapter. So just a couple things to remember, which was if we have the limit as x approaches some number, and our answer is infinity or negative infinity, this indicates a vertical asymptote at the number that x was approaching. So we'll see here if we have x approaches 2 from the left, that's this portion of the curve right here, we can see that our graph is heading downwards towards negative infinity. Okay? We can see if we approach 2 from the right, that's this portion of the graph here, this graph is heading upwards towards positive infinity. This tells us, since we're approaching either positive or negative infinity, we have a vertical asymptote at x equals 2. Now you might have one part of the graph going up and one going down. They might both be heading upwards towards positive infinity or both downwards towards negative infinity. You might have one half of the graph only. You don't have to have a left and a right here for this to be the case. But if either the left limit or the right limit approaches infinity or negative infinity, you have a vertical asymptote at that x value you are approaching. If x is approaching positive or negative infinity and you converge on an actual number, this is where we have a horizontal asymptote. So for example, in this case, we can see that as x approaches negative infinity, as x heads to the left forever, it is converging on a single y value of y equals 1. That means we will have a horizontal asymptote at y equals 1. So just a reminder, whoops, vertical asymptotes here, the line x equals a is a vertical asymptote if at least one of the following is true. You do not need all of these. So a reminder, if you have that little minus here, this meant approaching from the left. And if you had this little plus here, this meant approaching from the right. So this was from back in chapter 2 about limits. Okay. Also, if we have the limit as x approaches 0 from the left of 1 over x, this means that our x values would be very, very, very small and they would be negative. Okay? If I take any constant, it doesn't have to be a 1 on the top, it can be any constant on the top, and I divide it by a very, very, very small number, my overall value will be very, very, very large. Now, whether I'm positive or negative infinity is going to depend on if the constant is positive or negative and if I'm approaching from the left or the right. In this example here, we have 1 over a negative number, meaning we would approach negative infinity. In the second example here, we have 1 over a positive number, which means we would approach positive infinity. On a graph, this would look something like as x approaches 0 from the right, we're heading up towards positive infinity. And as x approaches 0 from the left, I'm heading down towards negative infinity. And again, because I'm approaching either infinity or negative infinity, I would have a vertical asymptote at x equals 0. Okay. Now again, any constant could be on the top. If it was positive constant, we'd be in the same two cases. If we had a negative constant on the top, from the left, we'd be positive, from the right, we'd be negative. So what I mean by that is if I had the limit as x approaches 0 from the left of negative 1 over x, this would be positive infinity, not negative infinity. Now we have a horizontal asymptote, y equals L, if x approaches either positive infinity or negative infinity and you converge on an actual number L. Okay. A reminder that if I take a constant like 1 and I divide it by a very, very, very large number, this is going to equal 0. If I take a constant 1 and I divide it by a very, 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 very small number like negative 500 billion, this is also going to equal 0. Oh, sorry, I think I just said 1 here, equals 0. Okay. So if I have 1 over something very, very large, or 5 over something very large, or 10, that top number could really be any constant. If I divide a constant by infinity, that should approach 0. Okay. Now, there's some practice questions there, but also just a little bit of a refresher about symmetry as well. So if you have f of negative x equal f of x, this is an even function and has symmetry about the y-axis. So again, this could be something like a quadratic, right? This has symmetry about the y-axis. And a function would be something like y equals x squared. And if f of x equals x squared, if I take f of negative x, this would be the same thing as negative x squared, which is also equal to x squared, which is our original function. If I have an odd function, that means f of negative x equals negative f of x. That would be odd and symmetry about the origin. So an example of something like that, something like this. So that was where if you had some point x, y, the matching point was negative x, negative y. On an even function, if we have some point x, y, the matching point is negative x with the same y value. Okay? So if I have an odd function here, something like y equals x cubed, that means f of x is x cubed. If I wanted to find f of negative x, I'm going to plug negative x into my cubed. This is the same as saying negative x cubed, which is the same thing as saying negative f of x, because f of x was positive x cubed, and f of negative x is negative x cubed. That makes that negative f of x, which makes this an odd function. Again, for more thorough notes on this, you would need to go back to chapter 2. Also with our limits, as x approaches infinity, we did have things like polynomials. Again, way back from chapter 2, have something like the limit as x approaches infinity of 3x squared or cubed plus 2 over, I don't know, 5x cubed minus 4x squared plus 3. Okay. Remember that it behaves like the highest power. So the top is going to behave like the 3x cubed. The bottom will behave like the 5x cubed. As x gets very large, the 2 is not going to matter. That 3 is not going to matter. And in fact, the 4x squared on the bottom also, as x gets very, very, very large, not going to matter. So this is equivalent to saying the limit as x approaches infinity of 3x cubed over 5x cubed, which would be the limit as x approaches infinity of 3 over 5, because these x cubes can cancel out. And remember, the limit of a constant is just a constant. So this would be 3 over 5. Okay? A reminder that if you have roots, you need to consider the root in the highest power. And if you're approaching negative infinity with a root, you need to be very careful, because when you plug negative infinity into a root, if you've got something like squared, then you're going to end up with a positive answer. Whereas if you plug negative infinity into something just like x, that will still be a negative answer. So again, if you need a refresher on how to do limits as x approaches infinity here, please go back to chapter 2 and take a refresher on that. That is all for this refresher section. Once you're comfortable with these reminder ideas, you can go on to the 4.4 lesson.